Welcome to today's lesson. Today's lesson we're covering 1-2 in the Go Math 8 book, and we are talking about sets of real numbers. So the learning target for today's lesson is I will be able to classify real numbers. So right now your calculator gives you answers when you plug numbers in and you do things. And your calculator is based on the set of numbers that's called real numbers. Every once in a while you end up with a kind of number where your calculator says syntax error or you can't solve it. So those kind of numbers are not real. Now, real numbers are kind of like biologists classifying animals. So animals are classified based on some characteristics. So for instance, a cardinal. A cardinal is considered an animal. It's considered a vertebrate. It's considered a bird and a passerine. So all of those classifications fit what a cardinal is, just like numbers can be put into different categories. And so the category we're going to talk about today are real numbers. Now, real numbers can be broken down into two sets. So you can either be a rational number, or it could be something that is an irrational number. Okay, rational numbers are numbers that can be written in the form of A over B. So typically what you guys would usually say is that anything that can be written as a fraction. So rational numbers are all of your numbers that are fractions and decimals. And they can be positive or negative kind of numbers. Now, kids for some reason like this word irrational. So if they aren't sure what a number is, they have a tendency to guess irrational. But an irrational number is really only numbers that do not terminate and they do not repeat. There's no specific pattern to them. So they keep going on forever and ever and ever with no specific pattern. So right now, if I ask you guys to think about some kind of number that goes on forever and ever and ever and has no pattern, most all of you guys come up with pi. Yes, we estimated it to be 3.14, but really if you put pi in, it keeps going on and there's no pattern to it. Now, other kinds of irrational numbers are square roots of non-perfect squares. So non-perfect squares. So what are numbers that are non-perfect squares would be something like the square root of 17, the square root of 20, the square root of 101. Now, if I asked you to take the square root of 9, yes, that's the square. But what is the square root of 9? The square root of 9 is 3. So this is what we call a perfect square, and it is rational. Perfect square. Okay, this is a rational number. So to be irrational, it would be a non-perfect square. So all of those numbers in between. All right, so rational, anything written in the form A over B. And so we have fractions and decimals. So right before rational, we have numbers that are integers. And what integers are positive and negative whole numbers. Positive and negative whole numbers. So something like 5, 7, -2, -4, all of those, anything that's positive or negative whole numbers. There are no fractions. Fractions and decimals go up in rational. Integers do not have any fractions. Okay, then we have something that are called whole numbers. And the first ones are called natural numbers. So if I ask you to just start counting, natural numbers. If I just ask you to start counting, you guys would all start counting with 1, 2, 3, 4, 5, 6, and so on. Those are your natural numbers. Sometimes they're called counting numbers, but you would just start counting. So after natural numbers, we have whole numbers. And the difference between natural numbers and whole numbers is because if I ask you, how many of you can see a live, real giraffe right now? From wherever you are, can you see a giraffe? Well, if we're just talking about natural numbers, you can't say the number 0 because we don't even have the number 0 in the natural set. So mathematicians had to make up another set of numbers and added the 0 in there. So 0, 1, 2, 3, 4, 5, and so on. So the only difference between a natural number and a whole number is that 0. Okay, a lot of times in the book, they're just going to be talking about whole numbers, integers, rationals, irrationals, and reals. So this set right here, having this chart down in front of you as you're doing your homework today would be good. Another way mathematicians like to organize it is something called a Venn diagram. So Venn diagrams have different maybe circles and bubbles in it. So all of the numbers that we talk about are part of the real number system. So everything that is in this box is a real number. And then real numbers are broken up into rational and irrational. So these are going to be your irrational numbers. And then we also have rational. Now, a subset of rational numbers is going to be your integers. So there are more rational numbers than there are integers. And a subset of integers is whole numbers. Okay, so the most restrictive is whole, and notice that rational and irrational do not overlap. They do not have any numbers that are in common. So let's try classifying a couple numbers here. So if we pick the number, let's just say 25, okay? 25, well, all numbers, so our directions are going to say classify, and sometimes that's all it says, classify. So the number 25 fits into a real number. All numbers are real. Now, is 25 rational or irrational? So rational numbers, any number that can be written in the form A over B. So can we write 25 as a fraction? Yeah, just put it over 1, 25 over 1. So it is rational. Now, we talked about terminating and repeating decimals before. So is this one terminating or repeating? Does it end or does it go on forever? And this one is what we would call terminating. And is 25 an integer? Well, if we have negative and positive whole numbers, so this one is an integer. And is it a whole number? Well, think about someone who starts counting. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Would they eventually say whole number? Yes. And we can't say all of them. It fits all of the classifications because if something is rational, it is not irrational. You cannot be both rational and irrational. All right, let's try another one. So let's pick the square root of 26. So if a kid started counting, a little 3-year-old started counting, would they ever say square root of 26? No. So it is not a whole number. Okay, is it an integer? Nope, not an integer because they're just whole numbers, but positive or negative. Is it rational? No. Well, this goes back to, remember in the first one when I said that irrational are square roots of non-perfect squares? So 26, the square root of 26 is a non-perfect. So this one is real and irrational. Real and irrational. All right, let's try another one. So let's pick -7. -7. Is that a whole number? So if a little 4-year-old started counting, would they ever start and go 1, 0, -1, -2? Or would they say 1, 2, 3, 4, 5? So -7 is not a whole number, but it is an integer, because the kid would say 7. And so what happens why we have the integers is because we also need the -7. So just putting in those negatives. So -7 is an integer. And can we write it as a rational number? Yep, because we can just put it over 1. So that means we can write it as a fraction. It is rational. Now, is that a terminating or repeating decimal? Well, nothing's repeating or going on. It is terminating at n. So we call this terminating. And all numbers are real. All right, let's try another one here. Let's try 3 and 1/3. Okay, what is 3 and 1/3? Is that a whole number? Would a little 3-year-old say 3 1/3, or would they just say 1, 2, 3, 4? So it's not a whole number. And an integer, remember if we go back here, and we look at integers, integers right here are positive and negatives. Where do we see fractions? Fractions fit under rational. So a fraction is going to be a rational number. And now, is that terminating or repeating? So you might have to just go ahead and do your long division and find out. Well, 1/3 and 2/3, those are repeating fractions. So this is repeating, and all numbers are real. All right, let's practice one more here. So if we take the square root of 81, the square root of 81. Now, some kids just look at that and see that square root. And because back here we had this square root sign, but notice I didn't say any old square root. I said your non-perfect squares. See down here where I said the square root of 9, that is a perfect square, that is rational. So let's go back to the example I have here and the square root of 81. What is the square root of 81? The square root of 81 is a perfect square. It is the number 9. So now let's think about that. Is that a whole number? Would a little kid eventually say 9? So it is a whole number. And if it's a whole number, that means it's also an integer. All integers are rational, and all numbers are real. Now, is that terminating or repeating? Well, because it comes out, this one is actually terminating. Okay, it terminates. So we're going to give some of these a try today. Another couple other things is every irrational real? And the answer is yes. All irrational numbers are real. Are all real numbers rational? Are all real numbers rational? And that answer is no, because some of them are rational. So not all irrationals are real. No, all irrationals are real, but all reals do not have to be irrational. Some real numbers are irrational. They're either one or the other. All right, good luck on your assignment today.